Sucrose and fructose are the most common natural sweeteners. We all know, however, that they add to our calorie intake and promote tooth decay. For these reasons, many people find artificial sweeteners to be an attractive alternative to them. Aspartame. This is the structure of aspartame, which is a popular artificial sweetener. The most successful and widely used artificial sweetener is aspartame, the methyl ester of a dipeptide formed from phenylalanine and aspartic acid. So it contains a phenylalanine structure and the aspartic acid. Aspartame is roughly 100 times as sweet as sucrose. It undergoes slow hydrolysis in solution, for which soft drinks should not be used after a certain limiting time. Because in the soft drinks, aspartame is present, so soft drinks should not be used after a long time, because the aspartame is actually hydrolyzed. It also cannot be used for baking because it decomposes with heat. So if you apply heat, this will decompose, and you should not intake those decomposed materials. Allium. This is the structure of allium. It is more stable than aspartame and roughly 2000 times as sweet as sucrose. Sucralose. Sucralose is a trichloro derivative of sucrose that is an artificial sweetener. Like aspartame, it is also approved for use by the US Food and Drug Administration. So FDA has permitted to use the sucralose in the foods. That means if you intake sucralose, that will not make any harm in your body. This is the sucralose, where this is the trichloro derivative. This one is chlorine, this one chlorine, this one chlorine. Sucralose is 600 times sweeter than sucrose and has many properties desirable in an artificial sweetener. Sucralose looks and tastes like sugar, is stable at the temperatures used for cooking and baking, and it does not cause tooth decay or provide calories. So it doesn't cause tooth decay, doesn't provide very much calorie, and this is also stable while cooking and baking. So that's why sucralose is used in food ingredients. Sucronic acid. Sucronic acid is a synthetic compound. Sucronic acid is 2 lakh times as sweet as sucrose. So this is very large amount, right? And this is the structure of sucronic acid. Cyclamate and saccharin. At first look at the structure of cyclamate, and this is the saccharin. Cyclamate and saccharin, used as their sodium or calcium salts, were popular sweeteners at one time. A common formulation involved a 10:1 mixture of cyclamate and saccharin that proved sweeter than either compound individually. Tests showed, however, that this mixture produced tumors in animals, and FDA subsequently banned it. So cyclamate and saccharin, these actually were used one time, but now these are banned by FDA, Food and Drug Administration.